Hello students! So this video here is about ratios and proportions, and guys, this is really in preparation for helping us for when we get to our similar polygons and proving similar triangles congruent. So again, we're going to go ahead on and get into ratios and proportions and really how to solve proportions, because guys, this here should not be a new concept to you. This here was probably discussed in like middle school, or if not in your previous and most recent math class. I'm talking to my students enrolled in my classes at our school. Anyway, let's go ahead on and get started on this right here with ratios and proportions. Let's go. Alright, so folks, in us discussing some of this background information about ratios and proportions, first off, guys, we need to realize that there is a difference between a rate, okay, a rate. There's a difference between a rate and a ratio. Guys, a rate is a quotient, and again, guys, by quotient, you should know that a quotient is like the result of division, right? So a rate is a quotient or division that's usually written as a fraction. So a rate is a quotient that compares two different types of quantities. All right, so guys, one example of a rate is like speed or velocity, speed. And I guess most of you will probably think of like a speed limit, right? Like 55 miles per hour, right? So that's considered a rate, 55 miles per hour. And again, it's a rate. It's comparing two different types of quantities. It's a quotient. It's some type of division that, and in this case, we can write it as a fraction. And again, if we wrote 55 miles per hour as a fraction, it would be as 55 miles divided by 1 hour, or 55 over 1 hour. And again, guys, we can have like equivalent fractions to that, right? So if you travel 55 miles in 1 hour, clearly you can travel 110 miles in 2 hours, right? And you can travel 165 miles in 3 hours, right? So, but again, all three of those different fractions are technically the same rate of 55 miles per hour. And again, another type of rate, or another example for a rate is maybe like your hourly salary, your wages, how much you make at a job, right? Let's say I forget exactly what the minimum wage is, $7.25, $7.50. Y'all have to let me know which one of those two it is right now, currently. Okay, I know I don't make the minimum wage, but again, and really, I really want them to raise the minimum wage. But anyway, we ain't talking about that right now. But anyway, folks, again, like $7.25 per hour. That's another example of rate. Anyway, let's move on. Okay, so guys, a ratio is a quotient that compares two numeric values. And it's different. It's different from a rate, because let's say that we had something like 3 blue squares and 1 yellow square, right? So if we were going to write the ratio, and again we'll talk more about ratios, but again, a ratio compares two values, or in other words, guys, two numeric values. And it pretty much says how much there is of one thing compared to another thing. Now, for those who remember how we can write out ratios, then this right here should look familiar. The 3 with that little colon and the 1. But just in case you don't remember certain things about ratios, we're going to remind you of those things. But again, folks, a ratio is a quotient that compares two numeric values. And again, folks, and when we say that it compares two numeric values, we mean that again, it pretty much tells you how much there is of one thing compared to another thing. All right. So again, folks, a ratio is a quotient that compares two numeric values. Folks, every ratio can be written or expressed in three different ways. So guys, we can use the word to between those the two values, like what you see over here to the right. If we were going to write a ratio of some value a ratio of some value A to some value B, like if it was like I said, you guys probably remember things like if you had a class full of 10 students, right? Just to remind you that this is not the first time that you guys have done this before. If you had a class full of 10 students total, and you had like five, if you had like seven girls in the class and 3 boys, right? 10 students total, 7 girls and 3 boys, right? It's not the first time that you've done something like this. Then if you had to write a ratio of the girls to boys, right? It's not the first time you've done this. Ratio of girls to boys. If we were going to write it using the word to, of course, it would be 7. We would write it as 7 to 3. So we would say that the ratio of girls to boys is, and we would write it using the word to, 7 to 3, right? Because there are 7 girls to every 3 boys, right? Or if we were going to use, and so again, that's one way that we could do it. We could use the word to in between the two values, or we can use the colon symbol. And again, that colon symbol is if you can see it right there. But again, we can use that colon symbol like that right there. 7 to 3. We still say the same thing. The ratio of girls to boys is 7 to 3, right? So for every 7 girls, there are 3 boys, right? That's the ratio. And so hopefully you guys remember that, because again, this shouldn't be anything new for you, okay? Or again, we could write it as a fraction, and again, we can use that fraction notation, meaning that we can write it as a fraction. And so if you were going to write it as a fraction, you would do it as 7. You would write it as, again, 7 over 3 if you were going to be doing a ratio of girls to boys. And so again, that's one way that you could do it. But yeah, all right. So again, those are 3 different ways that you can write out or express ratio. Again, you can use the word to, or you can use the colon symbol, which again is that symbol that I got right there. Okay, it looks a little weird. It's the same symbol that's used when you're telling time, right? The same symbol that's used when you're telling time, like 12 o'clock. That symbol right there is a colon, right? Like if you were going to write 12 o'clock p.m., that symbol right here, you see it. Don't act like y'all don't know what a colon is. That's a colon, okay? That's a colon symbol. That symbol right there, okay? Like 12 o'clock p.m., we can use that symbol between the two values. All right, don't act like y'all don't know what a colon is. Anyway, all right. So those are the 3 ways that you can write out or express a ratio. Okay, so let's look here again. Just a reminder, a refresher of how ratios work and how they're written. Again, folks, so if we had this little illustration with these shapes, you see here we got these circles, and technically these are rectangles. Now they're telling you that they're squares. We don't really have the proof that they're squares, other than us being told that they're squares. But anyway, we're not going to get into that at the moment. Okay. All right. So we've got these squares and circles here, and they say that if they want us to write the ratio of squares to circles, the ratio of squares to circles. So they're asking, how would you do that? So it's saying that again, a lot of people would write it as a fraction, and of course, if you wrote it as a fraction, that would be 3/6 or 3/6, because there are 3 squares and 6 circles, so that would be the ratio of squares to circles, right? How many squares or how many squares compared to how many circles? So 3 squares to 6 circles, so that would be 3/6 if we wrote it as a fraction. And again, folks, you could also write it using the word 2, so that would be 3 to 6, literally using the word 2, or you could write it using a colon, where you write 3 to 6. Again, you say it the same way. It's a ratio of 3 to 6, okay, because there are 3 squares and 6 circles. All right, so again, that's that. We're gonna look some more at this, and we're gonna look at what a proportion is, and then we're gonna look at some examples real quick. Okay, so folks, let's sort of get into the meat, really like the meat of what this lesson is really about. Let's get into the steak and potatoes. The steak and potatoes, okay? The real meat of what this lesson is on. All right, so here's a question for you. How do we determine if 2 ratios are equal? That's a good question, right? How in the world do we determine if 2 ratios are equal to each other? All right, so folks, the way for you to determine if 2 ratios are equal to each other is you take the 2 values and you take the first number and you divide that first number by the second number. So like if it was 3 to 6, then you would take the 3 and divide it by 6. Okay, but anyway. So again, folks, you can determine if 2 ratios are equal to each other by taking the first number and dividing it by the second number. And again, we're going to show you a quick little example of that because we're going to be segueing into and kind of transitioning into proportions with this. All right, so let's show you a quick example of what we mean when we say take the first number divided by the second number. Even though that's pretty self-explanatory, I'm still going to show you an example. Okay, so here we go with this example right here. Are the ratios 23 to 92 and 17 to 68, are those 2 equal ratios? So again, 23 to 92 and 17 to 68, are those 2 equal ratios? And so again, folks, if we want to find that out, what we literally do is we take for each ratio, we take the first number and divide it, literally divide it by, whether you want to write it like this with the little divide symbol, or write it as a fraction and literally divide. It doesn't matter how you write the divide, and as long as you take that first number, the 23, and divide it by the second number, 92, right? Because you get the same thing. Ain't that right? Yeah, that's right. I know. Thank you very much. So when you do that, you get 0.25 or 1/4, right? You get the same thing. 0.25 is the same thing as 1/4, correct? I hope you know that. Thank you. 25 cents is how much of a dollar? A quarter, right? Which is 1/4. I know it. Exactly. Okay. Wonderful. I'm so glad y'all know that. Awesome. All right. So, and then, again, if you take the second one, the 17 to 68, and you do the same thing with that, 17 divided by 68, however you write it, whether you write it with the little division sign or whether you write it as a fraction, it doesn't matter. If you write it as a fraction, it's still dividing 17 by 68, okay? 17 divided by 68, okay? Take the first number, 17, divided by the second number, 68. Okay, we get that, right? And some of y'all gonna switch it around. I hope that that's not true. I hope that y'all don't switch the two numbers around and say 68 divided by 17, and then wind up getting 4 instead of 1/4. But anyway, okay. So 17 divided by 68 is 0.25, and again, that's the same thing as 1/4, or 0.25 is the exact same thing. They have, and so you take the first number divided by the second number, and if they have the same value, then you know that they are indeed equal. That those two ratios are equal, right? If they have the same value. They're equal if you get the same value. For the quotient. And everybody should know that a quotient is the result of dividing, right? Okay, I'm glad y'all know that. Awesome. They're equal if you get the same value for the quotient. And we know that when we say quotient, we're talking about the result that we get after dividing. Yeah. So if you get the same result after dividing, then you know that those two ratios are equal. All right, moving on. Okay. All right, so folks, this right here is really something that's kind of important. The idea of having two ratios that are equal to each other. All right, so and again, that's kind of like a crucial and essential a key concept to us talking about proportions. Okay, you can't have a proportion without having two ratios that are equal to each other. Okay, let me explain. All right, so guys, a proportion is an equation in which two ratios are equal, guys, and the ratios are usually written as fractions when you have a proportion. Okay, so again, when I said that you literally cannot have a proportion without having two ratios that are equal, that is exactly true, guys. You really can't have a proportion without having two ratios that are equal to each other. Yeah, jabroni. I'm sorry, that was my wrestler voice. My bad about that. Alright, so a proportion is an equation in which two ratios are equal. And again, guys, the ratios are usually written as fractions. So guys, I got a question for you. How do we solve a proportion? That's a good question, ain't it, y'all? I know it is, right? Yeah. Alright, so how do we solve a proportion? Man. So, guys, in order for us to solve a proportion, it involves using a specific technique that is called cross multiplication. Again, we cannot solve a proportion, or I'll put it like this: the easiest way. I'm not going to say we can't solve a proportion without using cross multiplication, but guys, probably the easiest way for you guys is going to be because I know some other ways to solve proportions, but anyway, the easiest way for you guys is going to be to use a certain technique that is called cross multiplication. And again, folks, if I'm not mistaken, this should not be the first time that you have heard this before. The first time that you've done this with cross multiplying and solving proportions. So this right here, like I said, should be a review to you guys. Okay, but anyway, let's talk about cross multiplying, that little technique that we're gonna be using to solve proportions. Okay, so again, folks, in order for us to solve a proportion, we're going to be using a technique called cross multiplication. Okay, and again, folks, this should not be something that's new to you. So you see the proportion that's here, the A over B, and it's equal to where you got one ratio A over B, and it's equal to another ratio C over D, right? So and again here you kind of see those arrows there, and so when we say cross multiplication, we're saying that or let me explain it like this. In order for you to successfully cross multiply, you have to set the cross products equal to each other. Now, if you don't know what a cross product is, that's going to be very important. And so you can see here that I've got these two things. This product here that's equal to this product, right? So, guys, a cross product is the result of multiplying the numerator, and if you don't know what the numerator or don't remember what the word numerator is, we're talking about the top of the fraction, right? So a cross product is the result of multiplying the numerator or the top of a fraction, the top of one of the fractions, times the denominator or the bottom of the other fraction. So guys, in other words, in order for you to cross multiply, you've got to take the top of one of the fractions and multiply it times the bottom of the other fraction. So where you see the arrow here that's connecting the A and the D, that's connecting the numerator or the top of this fraction and the denominator or the bottom of this fraction, the top of this fraction and the bottom of that fraction have to be multiplied together. A times D. That's a cross product. A times D, the top of this fraction and the bottom of that fraction. Okay, I hope you get what I'm saying here. So that's one cross product, A times D. The other cross product here is again B times C, the top of this fraction and the bottom of the other fraction, right? Okay, so again, once you do your cross multiplying, you have to set those, or after, in order for you to actually have done the cross multiplying the right way, okay, you have to set those two cross products equal to each other. Okay, so again, folks, if we were using like actual numbers in a proportion, so again, this is a proportion because it has two ratios that are equal to each other. Okay, so again, folks, if you were going to use cross multiplying or cross multiplication, again, you would multiply the top of this fraction times the bottom of the other fraction. So again, that's 21 times 6, right? And that gives you a cross product of 126. And then the other cross product would be us taking the top of the other fraction and multiplying it times the bottom of this fraction, right? So that would be 14 times 9 or 9 times 14, whichever way you want to do it, right? Okay, but again, that still gives us our other cross product. So again, folks, that's how you cross multiply, where you have to set the two cross products equal to each other. Alrighty, we're gonna go ahead on and do some examples, and then we're gonna call it, okay? Because we really don't have a whole lot of time left. But again, we're going to look at maybe 3 or so examples, okay, of solving proportions. And again, we'll be using cross multiplication to do that, solving proportions. Alrighty, let's go ahead on and get this. Let's get it. Get it. Okay, so let's look at this example right here. Alright, so this one here says solve the proportion, and it says that the proportion is 47 equals 141 over x. Okay, I'm sorry about that. Equals 147 over x. Alright, so if we were going to solve this one right here, first off, some of you might be looking at this proportion and you might be saying, Mr. Starkey, I thought you said that a proportion was where you got two ratios that are equal to each other. Okay, some of y'all might be saying, is this a ratio, Mr. Starkey? Is that a ratio? The 47? Because you said it's supposed to be two ratios equal to each other. And you said a ratio should be able to be written as a fraction, right? Well, folks, can we write 47 as a fraction? Well, we most certainly can. Yes, it is a ratio. And we can write 47 as a fraction, can't we? And that's what we need to do. So that would be 47 over what number, right? 47 can be written as a fraction by writing it as 47 divided by what? 47 over 1. Okay, I'm glad that y'all know that any number divided by 1 is itself. I'm so glad that you realize that any whole number can be written as a fraction, right? Yeah, that's elementary school, ain't it? Okay, awesome. I'm so glad that we remember that. Yeah. Okay, so that's 47 over 1. And this is equal to 141 over x. So don't forget that, okay? Just because it didn't look like, it might not have looked like a fraction, but it is a fraction, okay? So yeah, we do have one fraction that's equal to another fraction. We got a ratio that's equal to a ratio, therefore we got a proportion. All right, let's go ahead on and solve that. I don't want to take up too much time here. All right, let's go ahead on and do this. Let's cross multiply here, folks, and let's go ahead on and get it. Let's get it. Yeah. Yeah, let's cross multiply. Alright, so let's go ahead on and let's do that there. So here we got the 47, and there we got the 141 over x. And so what we're going to do right here is we're going to go ahead on and we're going to take the x and multiply it times the 47. We're going to take the 1 and we're going to multiply it times the 41, times the 141, right? Because we know in order to cross multiply, sorry about that, guys. I'm tired. That's why I'm talking like this. We know in order to cross multiply, you got to take the you got to find the cross products, which means you have to take the numerator or the top of one fraction. Okay, so where you see the 47, take the top of one fraction and multiply it times the bottom of the other fraction, right? And you do the same thing with the top of the other fraction and multiply it times the bottom of the other fraction. Now guys, does it matter what order you put this in? Does it matter whether I put the x first or the 47 first, or whether I put the 1 first or the 41 first? No, it don't matter. It does not matter, guys. Okay? Right? The commutative property of multiplication says you can switch the order of multiplication, right? So it don't matter which order you put it in. It doesn't matter. I'm letting you know it don't matter which way you write it. That way or this way, it doesn't matter. It does not matter at all. Okay? So I don't really care if you write it in a slightly different way, in a slightly different order, as long as you make sure that you are definitely finding the right cross products. Okay, and setting those two cross products equal to each other. Alright, so again, you cross multiply by set the two cross products equal to each other. Oops, that's sloppy, but it's okay. Set the cross products equal to each other. Alrighty, so if we do that, and so now we have cross multiplied, but now what we need to do is now we need to go ahead on and finish solving. Alright, so now that we've cross multiplied, we need to go ahead on and actually solve for our variable. Yeah. Alright, so we cross multiply. Now let's go ahead on and solve. Let's solve our equation. Solve our variable. Let's solve the equation. Let's go ahead on and let's do it, y'all. Let's do it. Let's do it. Let's do it. Let's do it. Let us do it. Let us do it. Oh, I'm so tired, y'all. Okay, anyway, that's okay, because we're going to work through it. Alright, so x times 47 or 47 times x, we get the same thing, right? Yeah, we get, oh, what is that? What is that? Okay, yeah, alright. 47x, and then when you multiply 1 times 141, you get 141, right? So let's go ahead on and let's work this out. Let's solve it. Simplify and solve, right? So that's 47x equals 141, and then if we divide by 47 on both sides of the equation, that's going to give us 3. Yeah, because 3 times 47 gives us 141, right? I'm pretty sure that's right. I ain't got no calculator on me, but 3 times 40, yeah, 3 times 40 gives you 120, and 3 times 7 gives you 21, and when you add those two together, you get yourself 141. When you add that together, 47, and yeah. All right. Who that's tired? It's okay though. Alrighty. So again, if you divide by 47 on both sides of the equation, you end up getting the x is 3. So we have used cross multiplication, and then after that, after we set those cross products equal to each other, because that is the technique of cross multiplying, setting the two cross products equal to each other. After we do that, we solve for the variable. Okay. All right, let's move on. Probably not going to take up as much time explaining this next example as what I did explaining this one, because we're running a little short on time, and I want to have enough time to get up out of here and get this video uploaded before I leave here. Alright. Okay, next example. Alright folks, so let's look at this example here. Example 2 here, where they say solve the proportion, and here you see it doesn't exactly look like the last problem, like the last example that we looked at. And so here we've got x minus 6 over 5, and we have it is equal to x plus 3 over 2. And so guys, this is a proportion as well. I know it looks a little bit different, because we've got again, we've got what looks like x on the left side of the equation and an x on the right side of the equation. But again folks, since we do have one fraction equal to another fraction, it's a proportion. We can solve it by taking our steps that we need to take. And like I said guys, the first thing that we need to do here is cross multiply, right? Yeah. I told you guys that when we were solving this, we were going to be using this technique of cross multiplying, right? Okay, well let's do it then. So let's cross multiply, and let's go ahead on and get it. Let's get it. Alright, so if we cross multiply that, guys, I'm gonna go ahead on and not write it over again. I'm just gonna do it like this here. So if we cross multiply, and that would mean that we're multiplying the 2 times that x minus 6, right? So the bottom of this fraction times the top of that one, right? The 2 times the x minus 6. So guys, what do I mean by that? We're literally going to have to distribute. You're going to have to distribute, okay? Okay? Don't act like you don't know how to multiply 2 times x minus 6. Don't just try to multiply the 2 times the x. Okay, and don't just try to multiply the 2 times the negative 6. You need to distribute the 2 to both of those. Okay, all right, that's the distributive property. Don't act like y'all don't remember and don't know how to use the distributive property. Okay, don't act like I didn't say it like 4 or 5 times that you got to distribute the 2 into that. Okay, anyway, let's move on. All right, and then if you do the other cross product, that will be 5 times x plus 3. You're going to have to distribute the 5 into this. You're going to have to use the distributive property. Distribute, which is really just a part of us solving for the variable. I mean, if we had this equation with 2 on the outside of the parentheses and 5 on the outside of the parentheses, then we should know that a part of solving for your variable, it would be using the distributive property. Right? Okay. I would hope that you guys would remember that, because again, this shouldn't be anything new. as far as solving this type of equation after we cross multiply. Yeah. All right. So all for the variable. Let's move on. We got to hurry this up here. All right. So that's 2x minus 12. Okay, yeah, that's sloppy, but it's okay. And that's 5x plus 15. Let's get all our variables on one side. Subtract 2x. That gives us 3x. Okay, get all our constant terms on one side. Subtract 15. That gives us negative 27. So negative 27 equals 3x. Divide by 3 on both sides, and we get the x has to be negative 9. Awesome. Wonderful. Brilliant. Okay, we got that one there. Yeah, okay. I'm just going to leave that alone. All right, so that's how we do that right there, right? Same two steps. Cross multiply and then solve for the variable. Okay, don't forget, folks, that again, with what we had here, we had to distribute. Okay, because you literally had to take that whole quantity of x minus 6 and multiply it times 2, and you had to take the whole quantity of x plus 3 and multiply it times 5. All right, so again, you had to distribute there. Don't forget that. Oops, that's sloppy. Ooh. Okay, a little bit better. All right, next example, last example coming up. Okay, all right, so here we go, folks. Example 3, solve the proportion. All right, so again, we got a variable on the left side of the equation. We got a variable on the right side of the equation. We do have a proportion. We got one ratio equal to another ratio, and so again, this is going to involve us using that little technique, cross multiplying, right? So the first thing that I'm gonna need for you to do is cross multiply. And so, folks, when you submit your work for this assignment, I'm gonna need for you to show your work just like this right here. Okay, we ain't just turning in anything. I'm gonna need for you to show your work like what I'm showing you how to do right here. Okay, I ain't taking no shortcuts. I need for you don't need to take no shortcuts. And not that I'm saying that there are any shortcuts, because you need to do the work. It's math, you need to do the math, right? Okay, glad y'all understand. Wonderful. All right, so let's cross multiply. All right, so again, you take the cross product here, negative 2 times 6, and you set it equal to the other cross product, which is x times x plus 7. And again, folks, what are we going to have to do here with the x and the x plus 7? I'm so glad that y'all realize and remember that you're going to have to distribute that x, right? Because you're multiplying it times the quantity of x plus 7. You're not just multiplying the x times the x. You're not just multiplying the x times the 7, but you're multiplying it times the whole thing, the whole quantity of x plus 7, which means you need to distribute that x. Okay? The x is on the outside. You need to distribute. You need to use the distributive property. Alright, so again, negative 2 times 6 gives us negative 12. X times x gives us x squared. And x times 7 gives us 7x. Alright, ooh, looky there. We got ourselves a quadratic equation. Y'all see that? I see it. I'm glad y'all see what I see. Okay, quadratic equation. Okay, still the same steps. Solve for the variable. Again, this just so happens to be a quadratic equation. We've talked about solving quadratic equations, and I've even tried to bring it up on some of these more recent lessons, so that you have sort of like a reminder on it. So again, we tried to kind of bring it up several times in these lesson videos. But again, if you want to solve this quadratic equation here, most of you guys would probably solve the quadratic equation here by doing the by factoring or by using the quadratic formula. And these two are not the only options, but again, you could solve it by factoring, or or you could solve it by using the quadratic formula. All right, now, guys, remember that we're solving using either one of these methods here, using the solving by factoring or using the quadratic formula. Either way, for both of these methods, you have to set the equation equal to 0, and you have to make sure that the equation's in standard form. Okay. Set the equation equal to 0 and put it in standard form before you try to solve that. Equal to 0 and put it in standard form. In other words, you need to have it written in the form ax squared plus bx plus c equals 0, right? In standard form and set equal to 0. If you want to try to use either one of these two methods, that's where you're going to have to start off, remember, right? So you need to make sure the equation is set equal to 0. Ooh, okay, we got to hurry up here. All right, we're going to have to hurry this up. Hurry up. All right, so let's get this set equal to 0, and let's go ahead on and do that there. All right, so let's add 12 to both sides of the equation here. That's going to set this equal to 0, and that's going to leave us with x squared plus 7x plus 12. All right, guys, I'm going to show you very briefly. I'm going to show you both methods just to make sure that you remember how to use or how to solve by factoring and how to solve using the quadratic formula. I don't have a whole lot of time, so if it seems like I'm rushing through showing you this, it's because, yeah, I probably am. But it's not the first time that we've gone over these methods. So again, folks, you can go back and if I'm not mistaken, you should be able to go back and look at those past videos, lesson videos that I've made for you on solving quadratic equations, solving quadratics by factoring, and solving quadratics by using the quadratic formula. All right, so I'm going to show you both methods one at a time. If we do it by factoring, first off, let me show you that. So we got x squared plus 7x plus 12 equals 0. Remember, folks, we have to find two factors of that constant term. So in this case, the constant term is 12. We find two factors of 12. In other words, two numbers that multiply to give you 12. And they have to add to give you 7. They have to add to give you that middle linear coefficient. They have to add to give you 7. So two factors of 12, meaning they have to multiply to give you 12. They multiply to give you 12, and they have to add to give you 7, right? So what two numbers multiply to give you 12, that multiply to give you 12 and add to give you 7? Right? Well, that would have to be 3 and 4, right? 3 times 4 gives you 12, so they're factors of 12, and 3 plus 4 add to 7. Great. I'm glad that you guys know that. Awesome. Lovely. Brilliant. Okay. And again, folks, we write out those two factors, factoring out this trinomial. We write out the two factors as x plus 3 and x plus 4, and we write plus because these are both positive numbers, right? If one of them was a negative number, then of course it would be x minus that number, right? But again, since these are both positive numbers, we write x plus that number. Okay, I'm glad we get that. Awesome. Moving on, we set each factor equal to 0. and we solve. X plus 3 equals 0, set that factor equal to 0, and we set this factor equal to 0, x plus 4 equals 0, and then we solve each one of those equations. Remember, guys, that when we're solving a quadratic equation, there are usually two answers, two solutions. So we solve this, minus 3 on both sides of the equation right there. That gives us that x equals negative 3. Awesome. That's one solution. Minus 4, minus 4. I'm gonna have to really hurry up with the quadratic formula if I even got time to even show y'all that. We're gonna have to see about that one there. I'll try, but we'll see. A very quick version of using the quadratic formula. If I even got enough time. Alright, let's try. We'll try. Alright, so guys, remember that the quadratic formula, so again, you could solve by factoring, or you could solve it using the quadratic formula. And again, guys, there are other methods of solving quadratic equations, like completing the square, that you could use here, but most of you guys won't want to do that. And there's also factoring by grouping. Most of you guys won't want to do that either. So yeah, okay. So there's a reason why I mentioned these two methods. Okay. All right. So remember, folks, that the quadratic formula is that formula x equals negative b plus or minus the square root of, y'all gonna have to excuse the sloppiness, the square root of b squared minus 4ac. And we don't have a whole lot of time to be rewriting stuff and making it look exactly all the way neat as I usually would. So y'all had to just excuse the sloppiness. Guys, remember that when we said the first thing with doing the quadratic formula is making sure that you know what your A, B, and C are. And again, folks, if you've already got your equation in standard form, which this one was already written in standard form, right? We had x squared. So remember, the number in front of that was technically 1, right? X squared plus 7x plus 12. So the number in front of and I do apologize about the sloppiness, guys, but again, folks, it's in that form of ax squared plus bx plus c. So again, a is 1. The number that's technically in front of x squared is 1, right? The b, the number that's in front of x, is 7, and the c, that constant term, is 12. All right, so first you have to identify your a, b, and c. Remember, folks, I said the next thing that you want to try to do is find your discriminant. Your discriminant is that part that's up under the square root. That part that says b squared minus 4ac. So the first thing that I'd ask you guys to do when we were doing this was, after you identify your A, B, and C, go ahead on and calculate your discriminant. Plug in those values here. So that's 7 squared, which is 49. Wow, really? 49, okay. 7 squared times 4 times 1 times 12, which is 48. 4 times 1 times 12 gives us 48. And so 49 minus 48 just so happens to be 1. So again, folks, remember that this was the part here that was up under the square root. This is the number up under the square root, the discriminant, the number under the square root. Don't have a whole lot of time to do a lot of explaining. We've done a lesson on this already, but again, just trying to remind you how to do it. I gotta hurry up. All right, this is the discriminant up under the square root, right? So the part up under the square root, the number under the square root, that's the discriminant, right? That number up under the square root. So we have found that number under the square root to be 1. Okay, so the only other parts that I said that we had to do were the negative b. All right, so the negative b is the opposite, using the opposite sign of b. Remember, oh, I gotta hurry up, 3 minutes. Okay, I gotta go. Opposite sign of b, which is in this case negative 7. Okay, where you do the opposite sign of b, and then of course, guys, the 2a is, of course, guys, 2 times a. Right, multiply 2 times a. That's self-explanatory. All right, 2 times a. In this case, that's 2 times 1, which is 2. Okay, we know what 2 times 1 is. And then, guys, all you got to do is simplify from there. Okay, and I'm gonna show you that real quick. All you need to do from there is simplify. Negative 7 plus or minus. Technically, that's 1, and this is 2. And guys, I apologize if this is looking very, very sloppy, but again, folks, I'm out of time, so y'all just had to excuse the sloppiness of it. Okay, remember, folks, that this is 2 separate answers. One of the answers is going to be negative 7 plus 1 divided by 2. And the other answer is going to be negative 7 minus 1 divided by 2. Ooh, okay, I got to go. Where we at? And the other answer is negative 7 minus 1 divided by 2. 2 separate answers. Remember that, guys. So x equals both of those answers, and negative 7 plus 1 gives you negative 6 over 2, which is 3. And the other answer, negative 7 minus 1, gives you negative 8 over 2, which is negative 4. Okay, negative 3 and negative 4, which were the exact same answers that we had already gotten already anyway. Negative 3 and negative 4. All right, awesome. Bye. Gotta go. Hope it's been helpful. Really gotta go. Bye.